Okay, these are the solutions to Unit Test 2, and specifically questions 10 through 13. Um, and dealing again with factoring and rational expressions. And so here we go with number 10, which is dividing, right? That's a division sign right there. Dividing two rational expressions, dividing two fractions. And of course, how do you divide fractions? You don't. Instead, you um, take the divisor and you invert and multiply. You take the second fraction and you invert it and multiply. And that's all that went on here in step one. The x squared plus 6x plus 5 was the numerator. It's now the denominator. The denominator, 2x squared minus 5x plus 3, is now the numerator. Then from there, multiplying fractions now, right? Multiplying fractions. And typically to multiply fractions, all you do is multiply numerators and multiply denominators, but it makes it a little bit easier if you perform the factorization and any canceling that might result first. So what you're seeing here and what you want to confirm for yourself is how each piece, each numerator and each denominator gets factored. Probably the two denominators are easiest in that they're a 1x squared, so that makes them a little bit easier. Um, X squared plus 2x minus 15 is x plus 5 times x minus 3. And x squared plus 6x plus 5 is x plus 5 and x plus 1. And then the two numerators, people do have a little more trouble with these, although the one on the left is pretty easy because both signs are the same. And so it's got to be a 2x and an x, and they're both positive signs. And 1, the only way you're going to do that with integers is with 1 and 1. So that numerator on the left is pretty easy to factor. And all nearly as easy, I would say, the numerator on the right, because again, both signs are the same. We have both negative signs in terms of our factoring. Um, and so it's a 2x and an x, both negative. That means a minus and a 1 and a 3. Now from here, what you do is numerator to denominator, you compare and you can cancel in that way. So this x plus 1 and this x plus 1 in the denominator can be canceled. And likewise, the x minus 3 and the x minus 3. What we're sort of checking for was to make sure nobody was going to cancel numerator to numerator, because that would not be legitimate. And so final answer probably stays in the form of 2x plus 1 times 2x minus 1 over x plus 5 times x plus 5. All right? So that's number 11. Uh, number number 10 rather. Number 11 is a factoring exercise, and I did the factorization here. Um, because some people have asked for it, I'm going to also demonstrate the AC method that some people, that was new to them. And so the AC method, we multiply the coefficient of the square term and the constant term. And when we do that, we get 56. And from there, the factors of 56, 1 and 56, 2 and 28, 4 and 14, and 8 and 7. And we want to use the 8-7 pair because the 8-7 pair has a difference of 1. And what you do is you compare it to the B value. The B value is a minus 1 right there. So you would expand the factorization, and the B term that is, and you'd have 2x squared um, plus 7x minus 8x minus 28. So that bx, that minus 1x right there, got written using the two factors of 7 and 8 with a minus 8x and a plus 7x. Order doesn't matter there. You can put it in either order you like. I happen to choose this order. Now, you pairwise factor, and you notice the first pair, 2x squared plus 7x, have x in common. We factor out that x and get 2x plus 7. That should be clear. And then the last pair, um, both negatives, so I'll factor out the negative, and one a multiple of 8, one a multiple of 28, and so I'm going to factor out a 4 out of that. And when I divide a 4 out of each term, that leaves me with 2x minus 7, which, of course, is identical to what was left over from the first pair. We then factor out that 2x minus 7 from 2x plus 7, rather, from both terms. And so when you factor out that 2x plus 7 from both terms, you're left with an x minus 4 quantity, and that's your factorization. Right? So that's number 11. 12 is a division of fractions, only written one fraction over the top of the other, referred to as a complex fraction. All right. And just as it was in example number 10, the trick is to take the divisor, the x over x squared plus 2x plus 1, invert it, and change it into a multiplication problem. So we write down the numerator fraction here. We take the second fraction, and you can see that's been flipped. We then perform the factorization of x squared plus 2x plus 1 and get x plus 1 and x plus 1. Make sure this factorization makes sense to you. And then, numerator to denominator, we have some canceling. An x plus 1 with an x plus 1. And an x will cancel with one of the three x's that are multiplied together here. That's what x cubed means. And so it'll take that down to an x squared. So in the denominator, only a factor of 1 left, and we have x squared times x plus 1. So that's question number 12. Finally, question number 13, adding three rational expressions. And again, in order to add, the concept is common denominator, right? Multiplying or dividing, uh, no need for a common denominator, but when adding or subtracting, you need a common denominator. As you compare the denominators, it's fairly easy to tell what we'll use for a common denominator. We're going to use x cubed. So the first fraction would be multiplied by t squared over t squared. The second fraction would be multiplied by t over t. So that's still the form of 1, so you're not changing the value of anything. That then gives you, and of course the last fraction is all set because it's already a t cubed. And now we have our common denominator, and we write it as t squared plus t plus 1 over t cubed. And you're finished right there because um, there's no canceling. T squared plus t plus 1 is algebraically prime. There's no more factorization that can be done there. So there's 10, 11, 12, and 13 from test 2. And if you have any further questions about that, don't hesitate to get back to us.